it. All right. So we'll start with a review. Then we're going to move into solving non-right triangles. So 7-1, day 1. Right triangles. And this is just your SOHCAHTOA stuff. At this So if I give one here and 54 degrees here, can you?
90 minus 54 is the measure of angle B.
Yes, because A and B, if there's 90 used up here, you know they add up to 180. So to get angle B, the shortcut is just 90 minus 54, which is 36. Okay. So 1 down, 2 to go. Now, to find A or B, you have to use your SOHCAHTOA stuff. Yes?
The sine of 54 equals A over 10.9.
All right, so he's going to stand at the 54, and he's going to find A first. We have to use the hypotenuse. And the A is your opposite. The little a is your opposite. So if you still need that little helpful device, you can round. So he said it's a sine problem, so the sine of the angle opposite is the missing side little a over the hypotenuse. Make a proportion out of the left side, and it's just cross products and calculator work. So, what mode do we need to be in? Degree mode. So check your mode. I'm in degree on this. Make sure you close parentheses. Now I get that same answer. And we're back to sig figs. Looks like 3 sig figs. So 8. And then we'll find little b with trig. Could do Pythagorean theorem at this point, but let's use the trig to practice it. Which trig function are you going to use now if you stay at A? Cosine, because that's your adjacent and your hypotenuse. Okay, so cosine of 54 equals little b over 10.1. A little cross product. .94. Okay, so quick review, solving right triangles, SOHCAHTOA, it's how you're going to remember that forever, I think. But now, not all triangles are right triangles, so we've got to have a way to deal with those non-right triangles, which has been a while, but it'll come back to you, I think. So law of sines was the easy one. So here we go, law of sines. We'll solve angles, 2 angles and 1 side. If we don't have 2 angles and 1 side, we're going to have to use law of cosines, but that's for maybe Thursday or maybe after break. I don't know when we're going to get to it. So, we have non-right triangle. And remember, the sides across from the vertex is what we're going to use for the little letter. So this side, BC, would be called little a. Down here is going to be little b. And over here is little c. I'm not going to go through the big signs because I know you don't care. Nobody cares where it comes from. We just use it. So, law of sines says this is true. There's 3 proportions that are true in any triangle, even right triangles. If you take the side length and divide by the sine of its angle, whatever proportion that is, you will get the exact same proportion if you take little b and divide by the sine of its angle. And you will get the exact same ratio if you take little c So all it is proportions in any kind of triangle. So it's simple set of proportions across. Ready? You're going to solve triangle. Angle A is 39.75 degrees. Angle C is 30.35 degrees. And little b is 36.61 centimeters. So the first battle is labeling the triangle up correctly and getting everything in the right spot. So you start with any shaped triangle you want, because we don't really. And then you just label the three parts that are given. Angle A, 39.75 degrees, 35 degrees, and little b. Remember, little b has to go across from its angle, so that's down here, 36.61. We are missing little a, and we are missing little c.
180.
Yep.
180 minus the measures of angles A and C.
Yep, three angles of any triangle add up to 180. There's no shortcut for us to subtract whatever these two add up to. So 39.75 plus 30.35 0.9. Okay. Now we have to use the trig. We have to use the law of sines. So the law of sines is that proportion that has to exist. So we have to have a side and an angle that we know. It's right here with the B and the B. We have to know this to get started. We have to have a complete proportion. So I'll set it up. I know that 30. Now for note purposes, I'm going to show the little baby steps in between when it comes to homework. If you go from here to your answer, I'm fine with that. The A gets multiplied by the sine of 109. I saw it's not 9. The sine of 109.9. I saw the side of my triangle there and thought it was a 1. They don't want you to round anything. 36.61 is going to get multiplied by the sine of 39. And then the last step we're going to be doing is dividing, because that's A times sine of 109, dividing by that sine of 109.9. Now I pick up a calculator so that I only round at the very end here. The only parentheses you have to have are the ones around the angle. Calculator usage skills. Make sure you can do it. I know you can copy down, but can you get to the right answer? And sig figs, we're looking at 4. I'm getting 24.90. Anybody not able to get that? So and the last one's not necessary because the the calculator will automatically assume that that's there. All right, so 24. And then we do the same thing with the B. I could have done it over here and just done it backwards and done it. Is that okay if I come back to this, or should I start over? Because I'm still going to use this same. Start over or go up here? Crickets. Start over. 36.61. And now the other proportion that I'm going to use is with the C's. Little c I don't know, and then angle C. So little c of 30.35. And again, like I said, the skipping part, skipping that middle line, you always just multiply the two parts you know, and you divide by the one that gets multiplied by the letter. So I would multiply and then divide if you want to skip the middle step. It's your choice. I don't know how good see it. solving, I know I gotta divide. And did anybody,
19.67.
are we in agreement? 19.67? You asked me. But I do have a example 2. I would like you to find these decimals that we're rounding off are not exact. And here's what I know. Angle A is 60 degrees, square root of 2. So same process, we're still going to sketch the triangle, label the parts, set up law of sines, but then we're not going to grab a calculator. Where are we going to find exact values at? Circle sheet or left hand. So, there we go. Again, doesn't matter where you start the A, B, and C, because everything's in reference to... Angle A is 60, B is 75, and little c has to go across, is square root of 2. We are trying to find little a. Okay, so I have to have a side with its corresponding angle known. Well, I don't have one here, I don't have it here, and I don't have it C. You got to find that third angle, then we'll have the proportion. So a lot of them are two-steppers, so we got to find angle C. Subtract 60 plus 70. Good, thanks. These angles have to be something that are on our circle sheet. So now it's proportion time. So the proportion I see that we're going to start with, side and angle length, divided by the sine of the angle, law of sines, and the only thing we're finding fraction, which is the same as multiplying by the reciprocal. So we're going to be multiplying by this reciprocal right here. That'll leave us with the A on the right. And now let's just crank through this. What do you see happening over here that we can take care of before we actually multiply to keep our life so simple? Megan? You can cancel the 2 square root of 2's, leaving 1 in their place. Anything else? The 2's, the regular 2's also cancel each other out. What do we have left here? Just the square root of 3 times 1. So square root of 3 is our exact value. So same process, just couldn't use a calculator. Okay, last one. So what's going to make these challenging for you? You got to have a little challenge. Story problem. So last one, number 3. We have radio direction finders, A and B. Are 3.46 miles apart on an east-west line. From A, the bearing, remember bearings from earlier in the year, of a transmitter is 47.7 degrees. From B, its bearing is 302.5 degrees. Find the distance from A to that transmitter. So this is what's going to make these problems a little challenging. Story problem, you got to come up with the triangle. So, if you were on your own, how would you start this picture? Megan? Drawing, well, you got to know something. How are you going to start drawing a triangle? What are you going to draw first? What do we know for sure that I can draw? Where are you going to put A and B at if they're 3.46 miles apart? Isaac? Start with that east-west line. For sure, we know we got a line running horizontally east and west. So give yourself some room for this thing to grow. And I know A and B are on this line, 3.46 miles apart. That I know for sure. Do I know which one's A and which one's B right now? Well, let's go back to bearings. What are bearings measured from? I forgot that review. Bearings are measured from north. Which direction? Clockwise. So bearings, put that off to the side. Bearings are from north going clockwise. So both of these need a north reference line. So anytime you have bearings, you automatically want to put in that north reference line. Okay, like I said, do I know which one's A and which one's B? Remember, they're both going to be looking at the same transmitter. Let me put A over here for now. And it said from A, you're going to rotate about just over 45 degrees. So if this was A, I can rotate over about 45. That means the transmitter would be over there. That would make this B. B, I've got to turn how many degrees? 302.5 from the north. So there's 90, 180, 270, and then a little bit more. Are they looking at the same thing? So now I got to flip them. They're both looking in opposite directions. They're supposed to be looking at the same transmitter. So now I know that A is over here and B is over here. Now their lines of sight cross. Does that make sense? So you got to kind of play around with it to see if it works. So A is over here. B is over here. Now we're going to actually show that. Show the rotation from clockwise and label it. So over 47.7. Because what happens is people will put the 47.7 down here because this is the triangle we want. But the 47.7 has to come from the north, so make sure you put it in. Now from B, we're going to touch that north line and we're going to rotate 302.5 degrees. So I'm going to go in chunks of 90s. 90s to there. 180 is to the south. 270 is to the west. So I got to go a little bit more. So now I know where the transmitter is at. T for transmitter. Show that big rotation is 302.5 degrees. And our goal is to find the distance from A to the transmitter. Okay. So in order for us to use law of sines, we got to be able to figure out two angles inside of that triangle. How do I figure out two angles inside of that triangle? Isaac?
You can find the measure of angle TBA by subtracting 270 from 302.
So he's finding angle B. He says take 270 off of this. Does that make sense? Because think about it. We are 90, 180, we're 270 up to this line. And then we went past it. So if we went past it to hit 302.5, he's correct. Just take off a 270. So if we subtract off 270 from that, that's going to leave us with 32.5. Okay, found angle B. Need another angle. How can you figure out angle A? Megan?
Can't you take 90 and minus 47.77?
And why can we do that? How do you know that's a 90 there? You're correct, but do you know why it's a 90? Other than it looks like one.
In quadrant 1 to get to the 40.
Nope. Yep. Isaac?
North and west.
North line, east-west line. North and east-west are going to make 90 every time. So 90 minus 47.7 is 43.3? 42.3. Can we set up law of sines right now?
No.
No. We're missing, because we got to have a side with an angle. The only side we know is this one. We have to know angle T. How are you going to get angle T? 180 trick. So angle T is 180, subtract the two we just found, and let me know when you get there so we can move on. 105.2. So now we're ready for law of sines. That was a lot of work to get there, but we're ready. So it's side length over sine of its angle. So there's my proportion. And then the proportion we want, side we wanted to know was this one, which is over this angle here. And now it's just your cross products on the calculator. Let your fingers do the walking. Also the middle step. You don't have to if you're comfortable with just button pushing. And what's that distance that we're looking at? What's for sig figs?
1.93.
1.93. Sounds reasonable. Anybody want to verify? Got some head nods. All right. Okay, your assignment is on page 286. Four, 10, 12, 18, 28, and 30.